Hi, and welcome back to the Profundus video series. In the previous tutorial, we learned how to organize datasets and use batch operations to manage classes. Today, we will start our first training, review the most important settings, and use the resulting model to support the annotation process. Before we begin, let's briefly look at how computer vision works. During training, the model studies your annotated images and learns visual patterns associated with each class. It can then apply these patterns to new images and predict the location and class of similar objects. Open the Training tab. Here, you can configure several parameters that control how the model is trained. We will focus on the most important settings for this first training. The remaining options will stay unchanged for now, and we will examine them in more detail in a later tutorial. First, select the model size. Different sizes offer different balances between speed and performance. Smaller models usually train and run faster, while larger models may learn more complex patterns but require more computing resources. For this first example, select the tiny model. Next, set the number of epochs. One epoch means that the model has processed the complete training dataset once. More epochs give the model additional opportunities to learn, but training also takes longer. For this project, enter 50 epochs. The patient setting controls how long training continues without a meaningful improvement. If the model stops improving for the specified number of epochs, training can end early instead of using unnecessary time and resources. For this example, set patience to 20. The validation split determines how much of the annotated data is reserved for evaluating the model during training. A value of 0.2 means that 20% is used for validation, while the remaining 80% is used for training. Keep the standard value of 0.2. When training begins, the data is divided into a training set and a validation set. A pie chart shows the class distribution within both sets. During training, you will also see progress statistics such as loss, recall, and precision, which help you evaluate how well the model is learning. After training is complete, a window asks whether you want to use the model for predictions in the current project. This option requires enough annotated images, which should usually be the case at around 100 labeled images. Predictions can make further annotation much faster, so click Yes. Return to the Images tab. You can choose to display predictions only on images that do not already contain annotations. Open an unannotated image. Press Shift-H to show or hide the model's predictions. This makes it easy to compare the image with and without the suggested annotations. Press C to accept a prediction as an annotation. You can then adjust the bounding box by dragging its corners. To change the class, select and right-click the bounding box, then choose the correct class. You can also enter the new class name directly with the keyboard. When you are completely satisfied with all predictions on the current image, press A. Profundus accepts the predictions as annotations and automatically opens the next image. This shortcut allows you to review and confirm accurate predictions efficiently while moving through the dataset. Use the slider on the right side of the Images tab to set the confidence threshold. Predictions below this threshold are hidden. Increasing the value displays only predictions that the model considers more reliable, which can reduce visual clutter and help you focus on the strongest suggestions. You can also enable a trained model later. Open the Edit menu and select Preferences. Activate Use Custom Inference Model, and then click Select Model. In the next window, click Import, followed by Browse, to locate the model file. Open the project folder and navigate to the Runs folder. Select the file named best.pt and confirm your choices. Profundus will now use this model to generate and display predictions within the project, allowing you to continue annotation with model assistance. That's everything for this tutorial. Today, we completed our first training, reviewed the main training parameters, and used the train model to support the annotation workflow. In the next video, we will explore more Profundus features and continue building our understanding of the software. See you then.